Precalculus Spring 2017 ACP Preview Polar Coordinate and Polar Equation Problems. So we're going to go over 4 problems here. Problem 4, what are the rectangular coordinates of the point 5, 5 pi over 6? And what tells you this is a polar coordinate pair? Well, there are a couple things. One is that we say, what are the rectangular coordinates of this point? Well, because we're going to be asked to find rectangular coordinates, we can assume that this is going to be some other type of coordinate here. And I'm going to explain what these two numbers are in this polar coordinate pair. This one on the left, 5, is the radius. Okay, how far out from the center of that circle? So we're going to be 5 units out. And the second one is our angle. And how can we tell it's an angle? Because of this 5 pi over 6. Usually something in terms of pi is going to be an angle. Also, sometimes you'll see a degree symbol here. I find that my students work a lot easier with degrees than radians. So we take this 5 pi over 6, we can convert it to degrees by multiplying by the conversion factor 180 over pi. Well, pi over pi cancel, and what we're left with is 5 times 180 over 6, so we're left with 150 degrees. And this especially helps if our calculator's in degrees mode, which ours happen to be most of the time. So we're going to go on from here. There's an equation that we've gone over since the beginning of the semester. Our cosine is x. Our cosine theta equals x. And our sine is y. So we can find the x and y coordinates by just using this angle and this radius. So we can take 5 times, and I happen to know that the cosine of 150 degrees, or 5 pi over 6, is negative square root of 3 over 2. So it's going to be x equals 5 times negative square root of 3 over 2, which equals negative 5 square root of 3 over 2. And then y is equal to 5 times the sine of 150 degrees, which I know is 1/2, so that will simplify to 5 over 2. So rewriting this as a coordinate pair, I'm going to do this below. We're going to write negative 5 square root of 3 over 2, comma 5 over 2. And where do I see that? We see that right here, answer choice A. Alternatively, you can go to your graphing calculator, and I have a T-Inspire CX calculator. We can put in 5 times cosine 150 degrees and make sure that we're in degrees, which we are. So we get negative 4.33, and then we put in 5 times sine of 150 degrees. Should get 2.5, which we do. And we can just check our answers here for equivalency by just entering these numbers in here and see which are equivalent. Next, 5. The polar equation is used to produce the graph of the rows shown. Which equation is used to create the rows? Well, we notice that we have a radius out here at 3 units from the center, and so choices A and B are not going to work out on that account. So for choices C and D, which look like possibilities still, we can enter these as polar equations in our calculator. So we go to our calculator, and we get a page here. We push Control I for new page, add graph, get a graph polar equation, we go to menu, 3, 5 polar, and we put in 3 times sine of 4 theta. And we graph that. We do not get 4 petals, we get 8. So C is not going to be correct. We can go ahead and change that by going back. Change that to 2. And we do that. We do get 4 petals. So our correct answer for this is going to be answer choice D. Just enter these in the calculators. Pretty easy. Next, what are the polar coordinates of the point 2, -2? Now that we're working backwards, kind of a little more advanced. And so if we go, we can just try these ones. Now, what we can do is we can change all these. And again, my pre-calculus students are not as familiar yet with radians. We can convert all these coordinate pairs into radians. So this one here, 4 square root of 2, comma 7 pi over 4, that's going to be converted to 7 pi over 4, convert it to radians, degrees, by multiplying by 180 over pi. And we do that, we get 7 times 45, which equals 315 degrees. So this one here is going to be comma 315 degrees. And you can likewise, you can go one at a time and do that. This one here is going to be, next one to be 4 comma square root of 2. 3 pi over 4 is, I think, 135 degrees. 7 pi over 4 is going to be, what is this going to be? I got to put 2 square root of 2. It's going to be 315 degrees. And then our last one's going to be 2 square root of 2, comma 135 degrees. Now this point right here, 2 comma -2, which quadrant is that in? Well, that's going to be in quadrant 4, which means we have to the right, down 2. So this is going to be consistent here with 315 degrees. So anything that doesn't involve 315 degrees, we can just cross out. So we know it's going to be A or C at this point. And if we just go ahead and put this in, and I have a hunch that our correct answer is going to be C. If we put in x equals r cosine theta, we have, I'll put the formula here, cosine theta, we're going to put x equals 2 square root of 2 times cosine of 315 degrees. And also y is going to be equal to 2 square root of 2 sine 315 degrees. So we go over our calculator again. We go to another page, Control I. We get 2 times square root of 2 times cosine (315 degrees), and we should get 2, I hope. Yes, we do. We'll do it 2 times square root of 2 times sine 315 degrees. We should get -2, which we do. So the correct answer is, in fact, answer choice C. Okay, last one we'll look at here is which polar equation produces a spiral of Archimedes. Well, if we want to graph polar, I mean, we can only graph D right now. We can graph that as is. To graph these B and C, we'd have to solve for R. So we would get R if we divide by sine theta, divide both sides by sine theta, right? We get R equals 2 over sine theta. And similarly, for answer choice B, we're going to get R is equal to 2 over cosine theta. And we can graph these as is, or we can rewrite these reciprocal of cosine and secant. We rewrite this as 2 secant theta. And this one below is going to be R equals 2 cosecant. I'll just graph one of those to see what it looks like. We'll graph the 2 cosecant theta. So control I, add graph, polar, menu, 3, 5. We'll go 2 times cosecant theta. We go get our theta symbol here, and we get a horizontal line at y equals 2. And let's go ahead and try this answer choice D, because that's going to be the right one, 2 theta. So we go here and put in, oops, escape. Up here, we're going to put in 2 theta. And we go get the symbol here, go to the right, press enter, and this is an Archimedes spiral. And so that's a pretty distinctive thing. And so kind of by process of elimination, that's the only one it could be. Anyway, those are the 4 problems, sample problems for polar coordinates and polar equations. Good luck, and as always, thanks for viewing.